Hello everyone, welcome to a video on rewriting equations in formulas. In this video, we will learn how to rewrite literal equations. That means we're going to solve for a given variable, rewrite and use formulas for area, rewrite and use other common formulas, and use formulas to solve real-life problems. So what exactly are literal equations? So an equation that has two or more variables is called a literal equation. To rewrite a literal equation, we're going to solve the equation for a given variable in terms of the other variables. A formula we're probably familiar with. It shows how one variable is related to one or more variables. A formula is also known as a type of literal equation. Let's do some examples so we can really see what we're talking about. 1a and 1b are literal equations. Notice how 1a is written in terms of x and y, two variables, and b has a, p, r, and t as variables. So for 1a, they're asking us to solve for y, and for 1b, they're asking us to solve for p. So if I want to solve for y, that means that I need to move this 8x and this 7. We move the 8x since it's being added by subtracting. Now you might be asking, why not move the 7 first? Well, in previous videos, if you've watched those, we always move anything that is being added or subtracted before anything that is being multiplied. So 8x minus 8x, that goes to 0, leaving us with 7y is equal to, now right here this step is up to you. You can write 15 minus 8x, or you can write the minus 8x and then the 15. That is really your choice. My preference is always to write the variable first and then the constant. So I'm going to write it as the minus 8x, and then that is a positive 15. We are almost done solving for y. Now we have the 7 that is being multiplied, and the opposite of multiplication is division. Now there's two different ways that you can do the division. You can divide every single one of the terms by 7, and you will end up with y is equal to negative 8 over 7x plus 15 over 7. Or, let me rewrite the equation again here. And we can divide the left side by 7 and the right side, the full expression, by 7. This is still going to be just y, but this expression will be now as a single fraction of negative 8x plus 15 divided by 7. Now both of these equations are the same. If you were to plug in a value for x for both of them, the result will be the same for y. Now you might be asking which one is better. My preference is always going to be to divide each term separately, because later on we are going to end up graphing these type of equations, so it's easier to graph when each term is separated instead of having it as a single fraction. But both of these are correct. They represent the same equation. Let's try b. I'm going to rewrite this term in b so that instead of just being p, it is going to be 1p. And I'll show you in a second why. So this is 1p plus prt. You're going to notice that both of these terms have p, and that's what they're asking us to solve for. Now in the previous one, I only had to worry about one y to solve. But now I have two of these p's. I cannot add the first term and the second term because they're not like terms. So then what can I do to create a single p so that I can solve for it? We're going to do what is called backwards distributive property. Later on, you're going to know it as something different, but for now, let's call it backwards distributive property. And this is what I mean. If I had, let's say, a 5, and I was going to distribute this with a plus b. So for this one, the 5 will multiply the a, and the 5 will also multiply the b, leaving us with 5a plus 5b. You see how both of these terms have a 5? And that 5 came from this 5 being distributed inside this parentheses. So we are going to do the reverse here. Instead of distributing, we're going to go back to take out the p. So if I do the backwards distributed property, this would be the same as having a p outside a parentheses, and this p would be multiplied times the 1 and the RT. So that's why I wrote this one in here, so that if I took out the p, I know that I was supposed to multiply times the 1. So p times 1 will be p, and p times RT will be PRT. All right, let's get back to what they're asking us to do. They want us to solve for p. That means that I want to leave this p on its own. Well, the p is multiplying this parentheses, the whole parentheses, and the opposite of multiplication is division. So then I will divide this by the parentheses. Both sides, don't forget. So the left becomes a over 1 plus RT. Let me make this look like a 1 instead of an L. And on the right side, these are going to go to 1, leaving us just with p. And we have solved the literal equation for p. Now, before we go to another example, I want you to notice something. For this first one, we wanted to solve for y, so we moved anything that didn't have the y first, and then we divided by what was multiplying the variable we wanted to solve for. In this case, it reads that this is a formula for the surface area of a rectangular prism, and they want us to solve for h. So these two terms have h's. This first term doesn't, so I can move that one because it doesn't have an h. This is addition, so I'm going to subtract. The left side will be s minus 2lw. Don't lose the equal sign. That goes to 0, and I'm left with the two terms that have the letter h. Now, I want to make this so that I have a single h to solve for. I cannot add these two terms because they're not like terms, but we can do the backwards distributive property and take out those h's that they have in common. So we will take out the h, and in the parentheses we will write what's left over. So I have the 2l plus 2w. And you can check h times 2l will be 2lh plus h times 2w will be the 2wh. Don't forget about the left side. Almost there. Now that we have a single h, we need to remove this which is inside the parentheses. Well, this h outside the parentheses with no symbol in between means multiplication, so then the opposite will be to divide. So we're going to divide both sides by 2l plus 2w. So the left side we have s minus 2lw over 2l plus 2w, and we're going to leave it like that. We're not going to do anything else to the left side. On the right side, 2l plus 2w divided by 2l plus 2w, that goes to 1, leaving us only with an h, and we have arrived at our answer because they wanted us to solve for h, and h is already on its own. Not bad. Let's now move on to rewrite and use a formula for area. It reads, the area of a triangular painting is 126 square inches. So the area is 126 square inches. The base, let's call this one the base, is 18 inches. What is the height? All right. before we actually find the height, they want us to solve this by solving the equation for the height. What equation, you might ask? Well, let's put here, part A. The formula for area of a triangle is base times height divided by 2. I need to solve for h, so I need to move the b and the 2. Remember, we're solving equations. The steps for solving equation is, if you remember, parentheses, which we don't have any, and then we have to eliminate fractions, which we do right here, this 2. So we're going to do that. Since this is division, we're going to multiply both sides by 2. On the left side, we get 2a is equal to, the 2's get eliminated, and then we have still the base and the height. We haven't completely solved for h. We still have this multiplication by b, so we're going to divide both sides by b. On the left side, that leaves us with twice the area over the base is equal to the height. Perfect. We've done part A. We have solved for h. Now part B, they want us to find the height. So they want us to use the result from part A to find the height. Well, to find the height, we need to make sure that we replace the A, the area, and the base with those values that we were given. So this is 2 times the area is 126 divided by the base. The base is 18. So 2 times 126 is 252 divided by 18. That's going to give us a 14. So then the height is 14 inches. Moving along here to the other section of this video. Now we're going to rewrite and use other common formulas aside from the area. We're going to talk about the temperature. We're also going to do an example on simple interest. And the last one we're going to use is going to be the distance formula. Let's start with this one. They want us to solve this temperature formula for F. Okay, parentheses is king, but there is nothing for me to combine. There's no like terms in the parentheses. Then we do the fractions. So this is 5/9. The way that we eliminate 5/9 is to multiply by the reciprocal, 9/5 both sides. On the left side, we remain with 9/5c. On the right side, the 9 and the 5 get eliminated, leaving us only with the f minus 32. Almost there. Since we want to solve for f, all we need to move now is this minus 32, and we move subtraction by adding. Now, you might be tempted to combine the 9/5 with the 32, but you have to remember that this 9/5 has a variable attached to it, so these two are not like terms. This one has a variable, this one doesn't, so we're going to write them separately. On the right side, we only have an f because 32 minus 32 will go to 0, and we have arrived at our answer. We have solved the temperature formula for F. Let's now use that formula that we just solved for in this example 5. It reads, while on tour in Greece, Tatiana saw that the temperature was 40 Celsius. Find this temperature in Fahrenheit. Now, while we could use the original formula to solve for the temperature in Fahrenheit, if we look at the one that we solved for on the previous example, this will be easier to use because I already have it solved for Fahrenheit, which is what I'm looking for. And on this one, I will have to solve for F all over again. So this is not the best one to use. This one is. They tell us that the temperature was 40 degrees Celsius. So right here where I have the C, I'm going to replace it with a 40. Bring down the rest. If you remember, multiplying a whole number times a fraction, we multiply the numerator and divide the denominator. So 9 times 40 will be 360 divided by 5. That's going to give us 72. So then F equals 72 plus 32, making this a temperature of 104 degrees in Fahrenheit. Not bad. A couple of more examples. Example 6 reads, Sean's new car loan statement said that he would pay $4,866 with 25 cents in interest from a simple interest rate of 8.5% over 5 years. How much did he borrow to buy his new car? Because they're talking about simple interest rate, I am going to use the formula I equals PRT. I represents the interest. In this case, Sean is going to pay $4,866 with 25 cents. He represents the principal. This is the original amount. We are not given the original amount. As a matter of fact, that's what they want us to find. How much did he borrow? So this is the one that we are looking for. R is the rate. In this case, it's 8.5%, but it has to be in decimal form. So we're going to move this decimal twice to the left, and it becomes 0.85. Finally, T is time. And in this case, they tell us that the time is 5 years. Let's place them all in the formula. So the interest is $4,866 with 25 cents. We don't know the principal. The rate is 0.085 and T is 5. Before solving for P, I can simplify the right side expression by multiplying 0.085 times 5. So this is 4,866 with 25 cents. And then this on the right side is P times, well, these two multiplied is 0.425. Perfect. One more step. These two are multiplying. So then the opposite of multiplication is division. So I'm going to divide by this value inside the parentheses so that I can solve for P, the principal, the initial amount, which is what we're looking for. Perfect. The left side's division is 11,450. And on the right side, this go to 1, leaving us with 1P or just P. That means that Sean borrowed 11,450. All right. We already used the formula for temperature. We just used the formula for simple interest rate. Let's do an example on the distance formula. And it reads, a truck driver averages 60 miles per hour while delivering freights and 45 miles per hour on the return trip. The total driving time is 7 hours. How long does each trip take? Okay, so this truck driver is doing two things. It's going to deliver and is going to return back to where it started. The rate on each direction are the following: 60 miles per hour during the delivery and 45 miles per hour on the return. Let's see if we can figure out the time. I don't know anything about the time during the delivery, so I'm going to put an X. I also don't know anything about the time on the return, but I do know that the total is 7. So if the total is 7 and he takes X hours to get there, he has 7 minus those hours to return. So what will be the distance on each direction? We multiply 60 times x. Remember, distance equals rate times time. So this is 60 times x. And for this one, this would be 45 times 7 minus x. Let's create the equation then. The distance is the same for delivering and then coming back to where you started. So then the equation will be 60 times x is equal to 45 times 7 minus x. We're going to have to distribute these. On the left side, 60 times x is just 60x. On the right side, 45 times 7 is 315. 45 times minus x is negative 45x. We took care of the parentheses. There are no fractions. Now, there are no like terms on the left side or the right side to collect. So now I have to move my variables to one side. I'm going to move this minus 45 on the right side to the left side. 60 plus 45, that's 105. X is equal to 315 because this goes to 0. Last step to solve for x is to divide by 105. This is going to be x. And on the right side, 315 divided by 105 is 3. Now, what have we solved for? Well, remember, if we go back to this table that we created, x is the time it takes for the truck to deliver the freight. So let's write that here. The truck driver takes 3 hours to deliver. But they want to know the time for each of the trips, so delivering and returning. So if this is to deliver, remember 7 minus x is to return. So 7 minus 3, because x is 3, will be 4. So that is for the return. So the truck driver takes 3 hours to deliver and 4 hours to return. Not bad. I like these type of questions because it allows us to practice everything that we've learned in this unit, to learn how to translate words into equations. And now, not only that, we are using formulas to set up the equation, and then we have to solve these linear equations that are either simple equations, multiple step equations, or equations with variables on both sides to finally arrive at our answer. This is pretty cool. Let's go to the last piece for this video. And that is using formulas to solve real-life problems. So example 8 reads, acceleration is the measure of how fast velocity is changing. The formula for acceleration is below, right here. A equals BF minus VI divided by T. Now, A represents the acceleration, BF is the final velocity, VI is the initial velocity, and T is time in seconds. The one is to use this formula and solve for BF. Let me bring the formula. How do we start solving for BF? We have steps for that. There's no parentheses, but it is a fraction here. We need to move the denominator by multiplying. So we have a T on the left side. Could we have written TA? Definitely, but as you start working more and more with equations, you are probably going to be asked to write these in alphabetical order. On the right side, the T's get eliminated, and now we have BF minus VI. Now we have to check that there are no like terms. There isn't, even though both of these are V's. This one is has a subscript of F, and this one has a subscript of I, so we cannot combine them as like terms. The last operation that is here is subtraction. Since I'm trying to solve for BF and BF is being subtracted by VI, the opposite of subtraction or the inverse operation of subtraction is addition. So we're going to add VI, which is the initial velocity. So we get AT plus V sub I is equal to, well, that goes to 0, V sub F. These right here are read as V sub I, and this one is read as B sub F. This sub represents subscript. So this is V with a subscript of I, we just read it V sub I. V with a subscript of F, we just read it V sub F. Okay, we are done with part A. Let's do B. They want us to find the final velocity of a runner who is accelerating at 2 feet per second squared for 3 seconds with an initial velocity of 4 feet per second. Yes, we can use the original formula, but then we will have to solve for V sub F, or we can use the one that we already solved for in part A, which would give us our solutions faster. They give us that the acceleration is 2 feet per second, that the time is 3 seconds, and that the initial velocity is 4 feet per second. So 2 times 3 will be 6 plus 4, that will be 10. So the final velocity, which is what we're looking for, is going to be 10 feet per second. Let's write it down. And we have completed the last video for Unit 1. So I'm going to leave these 3 examples for you to try them out. Remember, if you're in a live class, come ready to go over these when we meet next week. And if you're in a self-paced, you can ignore these. Thank you so much for watching, and I'll see you in the next one.